Finally, construction on the Jeddah Tower, the world's first 1-kilometer tall skyscraper, is back online and strong after a rather long 6-year halt. Mind you, this amazing tower was originally planned to be the world's first 1-mile tall tower, but the height was reduced because the soil in the area was not suitable for such a colossal, immensely heavy tower. The Jeddah Tower, and yet another insane mega project by Saudi Arabia, which is implementing a $7 trillion nationwide program to turn the country into something straight out of this world, or rather, from the future. They're also succeeding as tens of mega and giga projects are nearing completion, such as Qiddiya Entertainment City, parts of the new city of Neom, and the Red Sea Global Project. This mesmerizing super high tower was not exactly a walk in the park in terms of engineering and design. Even the elevators are being custom-made with some of the latest technologies to make it possible for people to reach top floors comfortably and fast. What is Jeddah Tower, and why is Saudi Arabia building it? And what are the engineering and construction marvels utilized to make it a reality? Let's start by answering the question of why is Saudi Arabia so eager to build the world's tallest tower even though countries are technically no longer competing in that area because it costs too much and is simply not profitable? The answer is simple and consists of one word: tourism. For the past 100 years, Saudi Arabia has been getting most of its revenues from oil. However, in the past 2 decades, it mobilized towards diversifying its economy, and tourism has been one of the pillars it's focusing on to achieve such a goal. It has become a heavy industry, business, finance, renewables, technology, and bioengineering hub. And it also wants to become a major tourism hub not just for international tourists, but for its residents in the first place as part of its larger plan to turn the kingdom into one of the top 5 most sustainable and best places to live in the world. The focal point of the development in Jeddah Tower's primary use will be to house a 4 Seasons hotel, 4 Seasons short rental apartments, Class A office space, and luxury condominiums, among many other things. And of course, its sheer height means that it has the world's highest observation deck. It'll be a one-of-a-kind tourist destination. So what is Jeddah Tower? Jeddah Tower is an under-construction skyscraper on the north side of Jeddah, Saudi Arabia, and it's like no other structure ever built, because it'll be 1 kilometer tall and full of life and activities. Upon completion, it'll be 180 meters taller than the Burj Khalifa, thus becoming the tallest in the world. The foundation was completed in 2013, and about 1/3 of the structure was completed by 2016. However, activity stopped in 2017, but as of September 2023, construction is back online and it could be delivered as early as 2028. The design for the tower was created by American architect Adrian Smith, who also designed the Burj Khalifa. Thus, it's a better design too. Jeddah Tower is located on a 120-acre plot that will host numerous other buildings of unique design and purpose. This area will be the first of a 3-phase Jeddah economic city development, which has a budget of more than $20 billion. It's not quite clear how much the tower will cost. However, estimates put the figure around $2 billion, mainly because most of the materials, such as high-stress concrete and steel, are produced locally, and labor costs are about 30% lower than places such as the USA and Europe. Let's now decipher this tower in detail with a focus on its design and the engineering tricks used to make it a reality. In May 2008, soil testing in the area cast doubt over whether the proposed location could support a skyscraper of the proposed 1-mile height. This led the engineers to lower expectations and design the tower to be 1 kilometer high instead of 1 mile high. Mind you, it would have been great if they found a way around the soil issues and made it a mile high, because that would have been truly insane and attractive. But the fact remains that in the realm of civil engineering, geological issues cannot be ignored. The design for the foundation, which was constructed by Bauer in 2013, consisted of 270 board piles up to 110 meters deep, which were very difficult to install. Imagine this: some of the materials needed for the skeleton structure are 500,000 cubic meters of concrete and 80,000 tons of steel, if not more, so you can imagine the sheer weight of this amazing tower. The tower features 3 wings with a center core. The tower structure will be made of reinforced concrete walls and floor slabs. The walls consist of 3 core walls that form a triangle at the center of the tower, wing walls that extend along the long axis of the wings, and short fin walls that are perpendicular to the wing walls. Thus, there are no individual columns or super columns in the entire building because wall and slab structures combine to create a nearly infinitely stiff structural system from the center of the building to the extreme perimeter, which is why the foundation was ultra-reinforced and is of unique design. Just to give you a perspective on how strong the walls are, the wall loads range from 50 meganewtons for the small walls at the center of the tower to over 400 meganewtons for the walls at the ends of each wing. The total gravity load of the superstructure is about 8,800 meganewtons, including the raft weight. Thus, the resulting average pressure on the subgrade below the raft is about 2.37 megapascals. Hence, there is no surface tension loads at the foundation level. The footprint of the tower foundation raft is approximately 3,720 square meters, with a center-to-edge of the wing distance of nearly 60 meters. The raft is divided into 4 zones of roughly equal size, the 3 wings, and the center core area. The gravity load takedowns resulted in a uniform loading on the raft for the 4 zones plus or minus 15% from the overall average area load on the foundations. The foundation system for the tower is a system of 226 1.5 meter diameter and 44 1.8 meter diameter cast-in-place piles connected to a continuous concrete raft covering the entire pile field. The raft has a thickness of 4.5 meters at the center area and increases to 5 meters at the ends of the wings. The pile depths range from 45 meters at the wings to 105 meters at the center of the tower. So if you're an engineer or a fan of civil engineering, you can see that this structure is rigid, stiff, stable, and also earthquake-proof. Just a few days ago, 14 construction contractors from the region, Europe, and China have been given 3 months to prepare their bids for the completion of the project. Such a super tall building doesn't come without challenges. The sustainability of such a tall building would include problems such as vertical transportation limitations, with elevators only being able to go so far, building swaying caused by wind, and super column settling, which occurs because concrete tends to shrink as it hydrates and settles under load, whereas steel is dimensionally stable, thereby causing the floors to become uneven. One of the ways Jeddah Tower attempts to overcome these problems is with its smooth, sloped exterior design, which, although more expensive to build, offers superior aerodynamic performance over stepped designs such as the Burj Khalifa, allowing it to have a more conservative core overall. The Jeddah Tower is Y-shaped because a triangular footprint promotes stability and increases window views. The smooth slope facade of the tower particularly induces a beneficial phenomenon known as wind vortex shedding. It creates an infinite timing differential in air pressure exertion in any one particular direction, thus creating a more stable structure, as there is no broad area of outstanding pressure or depression at any given time. The building will have a total of 59 elevators, 5 of which will be double-deck elevators, as well as 12 escalators. The elevators will be made by the Finnish company Kone. It will also have the highest observation deck in the world, to which high-speed elevators will travel at up to 10 meters per second. To overcome elevator issues, the tower will use its large number of efficient elevators as well as its 3 sky lobbies, which allow transfers to be made between elevators serving a specific area, with no elevator being overburdened. We can only say that we cannot wait to see more details on the floor plans and interior design, and we'll definitely make another video once a bidder is selected and such plans are released. Thank you for watching, and please like, share, subscribe, and hit that bell icon.